Hello friends, today in this video I will be showing you how to calculate the flux, the electric flux through a disk. Okay, so we will calculate electric flux through a disk. Okay, so the original formula that we have to prove, or I will tell you the final answer. Okay, okay. So now we will just make a cone. It's not a cone, actually we are trying to take the electric flux through a disk. Okay, so let this be a point where charge q is placed. Okay, so this is the border line, and this angle is theta, and this angle d alpha. Okay, and this angle alpha. The this is r, this is x, and here we can have this circle as well as, I must make it again, sorry, it should be like this. Okay, so this is dr, this line is r, and this is r. Okay, so this is the case now. Okay, so this will be our diagram for this question. So now we have to find the electric flux through a disk. Okay, so we know that this, so now the electric field will, so now the electric field of this charge will pass here, which will be E, and the area vector will be like this. It would be dA, and here the angle will be phi, because these both are we should say that the lines are perpendicular, and this would be the transversal, so this angle will be alpha. Okay, so now we will write d phi is equals to E dot d a. Okay, so now integral of d phi is equal to E dot dA. Okay, so now the electric field will always be kq by r square. Okay, so now we will write, so according to formula it would be 1.4 pi epsilon naught, which is k, then kq upon r square. The r, actually the r we will be taking is this line which is joining this from here to here, so which is equal to x square plus this is small r. Okay, this will be the under root, and we will square it, so eventually it would become x square plus r square. Okay friends, so now here the electric field will be equal to so this is our electric field. We can write it as q upon 4 pi epsilon naught into x square plus r square. Okay, so here is our electric field. So now we can write that phi is equal to integral of q upon 4 pi epsilon naught x square plus r square into dA, where the area dA is equal to 2 pi r dr. Okay, so now 2 pi will be cancelled with 2. Okay, so here flux will be q upon 2 epsilon naught. Okay, it's q, okay, q upon 2 epsilon naught integral, and here will be r upon x square plus r square dr. Okay, so but I think I have done a bit mistake here, so now let me revise it. Okay, so it's okay, it is like this, and e upon 4 pi epsilon q. Okay, here it is correct. Then q into dA it would be 2 pi r dr. It's correct. Also, I just forgot to write cos alpha here. Okay, maybe cos alpha, cos alpha, cos alpha. Sorry, it should not be cos alpha. Sorry. It would be here cos alpha. Okay. So now here it would be, we will multiply it with cos alpha. So here the value of cos alpha is equal to x square plus r square under root upon, so it should be x upon under root x square plus r square. Okay, so now here we will multiply it with x upon under root x square plus r square. So now let me shift on to a new page. Let us remain here only. Okay, so now what we will do is we will just substitute this equation. Okay, so we will just combine this equation. Let me write it here. It would be qx upon 2 epsilon naught into r, sorry, it would be r upon x square plus r square 3 by 2 dr. Okay, so here it is. Now what we will do is that we know that x upon r, okay, sorry, r upon x is equals to tan alpha. Okay, so r will be equal to x tan alpha. So we will substitute this here. Qx upon 2 epsilon naught into r is equal to here the r is equal to x tan alpha. So okay, x tan alpha upon x square into 1 plus tan square alpha is 6 square alpha alpha. So here it's 3 by 2, so this all will get cancelled, and here it can be equal to x cube sec cube alpha dr. Okay, okay, so see here now we have to substitute, we will have to substitute dr. Now here we want d alpha. Okay, so for that we will just differentiate this equation, so it would become dr. See what we will do here, that it would be dr by d alpha is equal to the derivative of tan alpha is sec square alpha, so dr will be equal to d alpha sec square alpha. Okay, okay, so now we will substitute this here. So here it would be qx, we will mix star here, and so now qx upon 2 epsilon naught into x tan alpha upon x cube sec cube alpha into d into sec square alpha d alpha into sec cube alpha d alpha. So I want qx upon 2 epsilon naught into integral of x, so here it will become sin alpha. Okay, upon x cube d alpha, sorry. So now here that this would become so I think I have been doing a mistake since this. Okay, so cos alpha will be x, and dA is that it is correct. So I think that there is some problem in this. Okay, so I think I have missed some x here and there, so it's kq upon r square. Okay, so kq upon r square, so q upon 4 pi epsilon x square plus r square into something like this, so x upon this. Okay, we, so c, I have forgotten x, my x here. Okay, so it's actually r equal to x tan alpha. Okay, and dr upon d alpha should contain x here, so dr, so so dr must have x, so it should be dr is equal to x d alpha into sec square alpha. Okay, so it would be here, it should contain x. Okay, by mistake I forgot it, so here it would come x square. Okay, so not here, it would come here. We have to also multiply x with it. So okay, so it would be get, so actually it's x square, actually here it is x square, and it would cancel, and this will also get cancelled. Okay, so q upon 2 epsilon naught into integral of sine alpha d alpha. Okay, so now we can do like this. Okay, so q upon 2 epsilon naught into, here it will come 1, sorry, it will come minus cos alpha from 0 to theta. Okay, q upon 2 epsilon naught into minus cos theta minus cos 0. Okay, q upon 2 epsilon naught into 1 minus cos theta. So here is our answer, which is equal to a flux through a disk. So here is the total solution. You can take a screenshot of this solution. So kindly just subscribe to my YT channel, and for such content, and please help me to grow. Okay, so bye.